This is our come back there. This is our second review of exponential and log functions. All right, practicing for a test we have coming up. This is part 1 of the review. Part 2 will be the homework, which will be on another video. I got a question for you. Do you have a pencil in your hand? What? I'm sorry. I couldn't hear you. Yeah. Put it down. Alright, anyways. Looking at number 1. I've taught you to do this 2 different ways. One way to think about it. Whoa, let me zoom in. Remember, this is an invisible base 10 hiding in there somewhere. Invisible base 10. So one way to think about it is to cover up this 1 for a minute and just ask yourself, 10 to the what power is going to give you 1,000? Well, 1,000, see that how there's 3 zeros? That means this is 10 to the 3rd power. Okay, so 10 to the 3rd power is equal to 1,000. Okay, so that means the answer would be 3. Alright, but that's what the answer would be if it wasn't 1 over 1,000. Because it's really 1 over 1,000, you need this to be negative 3, because that's what it takes to drop you down to the denominator. So the answer would actually be negative 3. That's one way to do it. Here's the other way. This is log base 10 of, and here we have 1 over 10 to the 3rd power, right? 1,000 is 10 to the 3rd power. And this would be the same thing as log base 10 of 10 to the negative 3 power. Alright, negative 3 power, same as 1 over something. And then you can use the fact that log base 10 of base 10, these are going to cancel each other out, and that's just going to leave the negative 3. Alright, these are inverses. The exponent and the log base, they undo each other, so it's just going to be negative 3. So that's a second way to look at it. Okay, so you choose whichever way you like best. So similarly, number 2. One way to look at it is cover up that 1 and ask yourself, 8 to the what power is equal to 64? Well, that is 2. 8 to the 2nd power is 64, so the answer is simply 2. Alright, that's very straightforward. Oh wait, faked myself out. But okay, the answer would be 2, except for there is a 1 here. Can't just ignore it. It takes a negative 2 to drop you down to the denominator, so the answer must be negative 2. Okay, not 2. Alright, now let's see, the other way to think about it is this. We have log base 8 of 1 over, so 64 is 8 squared. So that would be the same thing as log base 8 of 8 to the negative 2 power. Alright? 8 to the negative 2 is same as 1 over 8 squared, because it drops you down. But then once again, log base 8 of base 8, these cancel each other out, and that's just going to leave you with negative 2. Okay. Now this one, there is no 1 over it in the first place, so that makes this a little bit extra easy. When you ask yourself 3 to the what power is equal to 27, well, that's 3. So the answer is just simply 3. Okay. Sure, you could even do this one the other way as well, by doing log base 3, and 27 is 3 to the 3rd power. Log base 3, you get 3. Alright, all of these problems you could do both ways. Now this one, because it has the x sitting here, really the best thing to do is to do it the second way with the canceling bases. Okay, so I really recommend you do it like this. This is log base 4, and 64 is 4 to the third power. Alright, and there's an x there, so just dink, just put it right there. So yeah, 4 to the third power is 64. Okay, don't forget the x. A lot of kids just left the x off, and that's no bueno. So the log base 4 and the base 4 will undo each other, and you will just be left with 3x. Alright, the x is part of it. Do not take it off. Okay, same thing here. Natural log implies an invisible base e. Log base e and base e cancel each other out. So that is just going to leave 3. That's why the answer is 3. Alright, not e to the third, not natural log, just 3. Okay, we are cooking now. Let's see, number 6. Well, this is an invisible base 10. So once again, you ask yourself, 10 to the what power is equal to 10,000? Well, count those zeros, right? This is 10 to the 4th power, so the answer will simply be 4. Alright, if you forget about the 0 thing, you can always use the chart. 10 to the 4th power, that's 10,000. Alright, number 7, equally easy. Once again, you ask yourself, 3 to the what power is going to give you 243. Just use your chart. There's 3, there's 243, that's the 5th power. So the answer is simply 5. Alright, very straightforward. Now, this one is a little bit less straightforward because you're still asking yourself 25 to the what power is going to equal 5. But wait a minute, if you put 2 or 3 or anything like that, that's just going to make this bigger. How can we go from a bigger number to a smaller number? And the answer is, this is really doing some sort of a root. Alright, we're doing a root. That's how you turn a 25 into a 5. And particularly, it would be the square root. Alright, the square root of 25 is 5. So you just have to remember that the square root is the same thing as the 1/2 power. Alright, so 25 to the 1/2 power is 5. So that means 1/2 is your answer. Okay, this one, again, we can do it this way by covering up the 1 and first asking ourselves, 5 to the what power is 125. That would be 3, alright, 5 to the 3rd power. Since it is 1 over 5, then let's make that a -3, and that will get the job done. Alright, by the way, if you ever want to check your answer, okay, we're claiming that, you know, we always are asking ourselves, like, starting with the base, 1/5 to the what power is equal to 125. We're claiming that -3 is that power. So you could check it and see. Alright, so what if we actually did a power of -3? Remember, negative power, you do the reciprocal and make it positive. So the reciprocal here would be 5. So that would be 5 to the 3rd power. And of course that would be 125, just like we want it. So when in doubt, check your answer. See if it actually works. Alright, if it doesn't, rethink it. Alright, number 10. Okay, man, a lot of kids had trouble with this on the quiz. Obviously, 64 is not on the chart. It only goes up to 10. And in fact, there is no single number that's going to turn a 64 into a 512. But let's still start off like normal. 64 to the what power is equal to 512. The key is we need to change both of these into a common base. So let's see. If we can find one row that has 64 and 512 in it, we are golden. So let's see. There's 64, no 512. Oh, look right here. 64 and 512, both in the 8, the base 8 row. So this is 8 squared, and this is 8 to the third power. Okay, so that means I can write both of these as a base 8. So I can write 64 as 8 squared, alright, that x I'll just put right here and make a 2x. And this 512 is 8 to the third power. They have to be the same base. Alright, since they're the same base, then logic tells us that the exponents have to be the same. In other words, 2x must equal 3, and you can divide by 2 on both sides. So you see that x would then be 3 over 2. So that is the answer. Alright, absorb that. Number 11. Alright, now we're condensing. Alright, step 1 is to take all of these coefficients and make them into powers. Okay, so that's going to go over there. So this will then be natural log 6 plus natural log x to the third minus natural log y squared minus natural log 5. Now, when you condense, you're only going to have one log. So all these 4 terms are going to turn into one term. Okay, natural log. Now I see I have positives and negatives, so right away I know it's going to be a fraction. Any positive term is going to contribute to the numerator, and any negative term will contribute to the denominator. So I've got 2 positive terms. Okay, right here and right here. These are both positive. So that's why I'm going to have the 6 and x to the third power in the top. Now these negative terms are going to contribute to the denominator. So that's why I'm going to have a y squared in the bottom and a 5 in the bottom. Traditionally you would put the 5 before the y squared. If you put y squared and then 5, I'm not going to mark it wrong, it just looks a little funny. But that's the answer for number 11. Number 12. Alright, we're still condensing, so we're doing the same thing. So these coefficients are going to become powers. So this is going to be log base 5 of x to the third power minus log base 5 of y to the 1/2 power. Remember that 1/2 power is the same as square root. So when you're condensing, you're going to want to make this a square root later. Now, any positive term will contribute to the numerator. So this is positive, so I'm going to have x to the third power up there. This term is negative, so I'm going to have my square root of y down there. Alright, that's it for number 12. Now, with number 13, we're going in the other direction. We're starting with one log, and we're going to expand it into multiple terms with log in it. The key is to not see this as two things. And please don't think that this is cube root. This is a to the third power, alright, and this is square root. So, anyway, square root. We need to handle this square root. So I have a to the third power. You know that square root is 1/2 power. So this will be 6 to the 1/2 power and b to the 1/2 power. You have to see this as 3 separate things. 1, 2, 3. So I will have 3 terms when I expand this. Alright, so I'm going to have log a to the third power plus log 6 to the 1/2 power plus log b to the 1/2 power. Okay, as a final step, you have to remember to put these exponents in the front as coefficients. So your final answer will be 3 log A plus 1/2 log 6 plus 1/2 log B. So there's your answer to number 13. Alright, number 14. The biggest mistake I saw was that a lot of students treated this as one thing, 7x squared, when in fact you have to treat this as two separate things. Alright, so really we have a 4 and a 7 and an x squared. There's 3 separate factors, and so we will have 3 separate terms in the answer. So we'll have natural log. This is in the numerator, so that's going to give us a positive term. These two things in the denominator will give us negative terms. So I will have minus natural log 7 minus natural log x squared. Of course, the final answer, you have to put that power in the front. So the final answer will be natural log 4 minus natural log 7 minus 2 natural log x. Alright, so many kids just try to give me natural log 4 minus 2 natural log 7x. Now this is a mess. Okay, that has to be split up, so don't do that. Alright, number 15. Working with decimals. Hopefully you learned in elementary school how to change a decimal into a fraction. Alright, when we look at 0.25, this 2 is in the tenths place, and this 5 is in the hundredths place. Okay, so if looking at the 0.25 as a whole, we can say that this is 25 hundredths, and that's how we're going to look at this. So this is the same thing as having log base 25 over, well, you know what, let me do this separately. So we have 25 hundredths, but this obviously will reduce. Alright, if we divide both of these by 25, that's 1/4. So let's just go straight to that. So we have log base 1/4. In fact, I mean, you really should just memorize that 0.25 is 1/4. Alright, it's a quarter, like think money. Anyway, so log base 1/4 of 1024. So we worked several problems like this on the other page. So once again, one way to do it is to disregard this 1 for a moment and then just ask yourself, 4 to the what power is going to give me 1024. So looking at the chart, 4 to the 5th power is 1024. Okay, so far that would mean that the answer is 5. But it's not a 4. It's really 1/4. Alright, so because it's a fraction, it will take a negative 5 power to make this into 1024. Okay, so the answer is -5. And remember, the reason for that is because it's 1/4, if you have a negative power, that makes it the reciprocal. So it turns it back into a 4 to the 5th power, which will give you 1024. So that's just checking your answer. Okay, number 16. Which of the following is not correct? Alright, so this is really 5 problems in one, because you have to look at each one of these and make sure that it makes sense. Well, I could take this 5 and put it as a power, couldn't I? Like that. I could move that 5. So then I'd have log base 3 of 4 to the 5th power. Well, what is 4 to the 5th power? 4 to the 5th power is 1024. So that would be the same thing as having log base 3 of 1024. So A is correct. So we're looking for the one that's not correct, so that's not it. So how about B? Well, think of condensing on this one. If you condense this, you're going to wind up multiplying these numbers. 6 times 5 is 30, so that's how this works. So that one is also correct. Same thing for C. If you were to condense these, I should have made one of these division. Anyway, if you can condense these, 5 times 12, that's 60. So that's correct. So we got to keep looking. This one looks weird. Let's see. Well, if we condense these, this is subtraction. So that would give us log base 5. Subtraction condenses down to division. So I'd have to do 15 over 3. Alright, but that would be log base 5 of 5. And what's the value of that? Well, 5 to the what power is equal to 5? Guess what? 1. So this has a value of 1. So D also works. So E must be the one that's wrong, alright? It's just a matter of figuring out why it's wrong. Let's just be sure in case we made a mistake on one of the other ones. Alright, well we have log base 3 of 6 minus log base 3 of 5. So would that be log base 3 of 1? Because 6 minus 5 is 1. That's the trap. That's the trick. But you're not falling for it, are you? Because you know that if you were to do this, condense this, this would become division. So this would really be log base 3 of 6 over 5, which is not log base 3 of 1. Those don't match. So E is the answer because E is the one that is not correct. Alright, so that was number 16. Number 17. Alright, these problems gave you guys fits on the quiz. So focus, absorb it. We're given, how many of these? 3 values. So we're given log base 5 of 8, 7, and 10. So our goal is to write everything in terms of 8, 7, and 10. So looking at 512, first we check the chart. Is it on there? Look, there's 512 right here. That is 8 to the 3rd power. Wait, I'm sorry, did I say 8 to the 3rd power? That's one of the things that we're looking for. So that is fortunate indeed. So 512, that would be 8 to the 3rd power. Now we've learned that this exponent could be put in the front. Let's use that to our advantage. So we have 3 log base 5 of 8. Now log base 5 of 8, that's one of the things we were given. So this becomes 3 times 1.29. Just put that in your bootleg calculator, because that's the only one you'll be allowed to use. 3 times 1.29, that is 3.87. So that's the answer to number 17. Okay, number 18. 56 and 10. Now 10 is one of the ones that we wanted, so that's good. So we just need to deal with 56. Well, if you know your multiplication facts, when you look at 56, the first thing that pops in your head should be, oh, well, that's just 8 times 7. So this is log base 5 of 8 times 7 over 10. So there's all 3 of the things that we wanted, just like that. Now let's expand this. Using these 3 factors will become 3 terms. So I have log base 5 of 8 plus log base 5 of 7 minus log base 5 of 10. Notice the two factors in the numerator turned into positive terms. The one factor in the denominator gave us a negative term. That's always the way it works. Alright, anything in the denominator is going to wind up in a negative term. All three of these things are facts that we are given. So this first one is 1.29. The second one is 1.21. And the third one is 1.43. Alright, so you can just do these two at a time using your bootleg calculator. So 1.29 plus 1.21, that's 2.5, then minus 1.43. I feel like I just did something wrong because I don't remember this answer. Alright, so that is the correct answer. Number 19. Similarly, as I'm looking at this 800 and I'm trying to get a 10 or a 7 or an 8 out of it. But right now the 8 is looking really promising because I see 800. And then if I think about it for just 2 seconds, so 800, is 8 times 100. But then as I look at the 100, 100 is 10 times 10, or 10 squared. So so this is what we're dealing with. We have log base 5 of 8 times 10 squared. So now I've got my 8 and my 10. Alright, and some kids would prefer just to do log base 5 of 8 times 10 times 10, and you will have 3 terms, and that works too. But I'm going to do it this way. So as I expand this to addition, this will be log base 5 of 8 plus log base 5 of 10 squared. But I'm going to put this 2 in the front. So that's 2 times the log base 5 of 10. Okay, so now I'll just put in all of these facts. So the first one is 1.29. So that's plus 2 times, and this one is 1.43. Okay, so that's 1.29 plus, go ahead and do this multiplication. Alright, so that's 4.86. No, I lied. What I mean is that is 2.86. Alright, you add those together, and that's 4.15. Alright, so there's your number 19. Okay, now these next 3 problems were the 3 most commonly missed problems on the last quiz. So really, you might have to do these over a few times, but make sure you can do them by yourself, like tomorrow. The first step of solving all of these, finding these missing variables, will be to rewrite these in exponent form. So start with the base. So this has a base of a, so if I sort of bring that down, now these two, everything else is going to change sides. So the -4 is going to come over here, and the 625 is going to go over there. Okay, so to me, the easiest thing to do, because all I want to do is get a by itself, the easiest thing to do is to multiply this by the reciprocal, which would be -1/4. Alright, because that's going to cancel everything out. The 4's cancel out, a negative times a negative is a positive, so I'm going to wind up just with a, okay, if I do that. Now, so what I'm really doing is I'm raising this to the negative 1/4 power, all right, and of course you multiply. But I have to do the same thing to both sides of the equation. So I will also raise this to the negative 1/4 power. Okay, now remember, a negative power is going to drop you down to the denominator. So this will become 1 over 625 to the 1/4 power. Now, so just remember that the 1/4 power is the same thing as a fourth root. Okay, in your mind, as you look at this, you should be thinking the fourth root of 625. And you can do that right off the table here. All right, fourth root of 625 is 5. All right, don't forget that it's in the denominator. Some kids just ignored the whole denominator part. So this would be a is equal to 1 over 5 because the denominator is 5. So that should be your answer. A is equal to 1/5. Okay. Again, on this one, let's rewrite this in exponent form. Let's start with the base. Alright, so the base is 1 over 256. Okay, everything else is going to switch sides. So this is going to come over here and become the power, so negative 3/4, and the x is going to go over there. So look, I already have x by itself, so all I have to do is simplify this. Do you remember what you're supposed to do when you have a fraction and a negative power? You're supposed to do the reciprocal. So the reciprocal of this would be just 256. You know, 256 over 1 is just 256. And then I can put a positive 3/4 power. Okay, now, do you remember that when you have a fractional power, this 3 is the power, and this 4 is the root. Power over root. So let's go ahead and rewrite this in radical form. So it's a fourth root of 256, remember? And then it'll be all to the third power. So we can do this from the chart. So fourth root of 256, is 4. Alright, so that's why we'll have a 4 in there. But then I have 4 to the third power. 4 to the third power is 64. So that's why x is 64. Okay, number 22. N is already by itself, so all we have to do is evaluate this. So we don't actually need to write this one in the other form, but we can. Let's go ahead and write it in the other form. In the other form, we'll start with this base. Alright, 1296. These two things are going to change sides. So I've got 1296 to the n power is going to equal 6. Alright, so we're asking ourselves, what power will change this into this? Now, you know, I've already got this big number. If I raise this to some kind of a power like 2 or 3 or 4, obviously it's just going to get bigger. If I did a negative number, that's not going to make it smaller. It's just going to drop it down to the denominator. And then I'll have a really big number in the denominator. So that's not going to help. A negative power won't help. What kind of a power is going to change a big number into a small number? Well, I'm hoping that you're thinking it's going to be some type of a root. Alright, a root will turn a bigger number into a smaller number if it's the right two numbers. So it's going to be some kind of a root. So the question is, well, let me not use n. Let me just put a little question mark. The question is, what root will change this into a 6? Is it square root, third root, fourth root, what? Alright, well, let's look at the base 6 row and see. Alright, 1296. Okay, so looking at the base 6, I see the 1296, and that would be the 4th power. So looking backwards, the 4th root of 1296 would be 6. So it's the 4th root is what it would take. Okay, so in your mind, you should be thinking, what we need is the 4th root. Alright? Now, this all is in your mind. So the 4th root is the same thing as a 1/4 power. Okay, so that's the key that you had to remember. So this is like having 1296 to the 1/4 power. So that means our n needs to be 1/4. So that's why the answer to number 2 is 1/4. Okay, just let it soak in. Alright, that was number 22. I think we have one more problem. Alright, this is a next level problem. Alright, you might have to watch this video a couple of times. Please do not copy this down. Do you have a pencil in your hand? How many times have I told you? Okay, I'm not joking. Put the pencil down. Watch the video, learn how to do it, but then see if you can go back and do it by yourself. If you can't remember it for 5 minutes, then you don't know it. And it's better you find that out now rather than on the test when you get yet another problem wrong. So, here's the strategy. Strategy. I'm going to break this down into pieces. So this part in here, I'm going to call that Q. Alright, now this entire expression in here, I'm going to call that P. Alright, I don't care what you call them, but this helps me. So this entire thing is P, alright, as I've indicated. So that means I could look at this entire equation as log P is equal to 0, okay? Alright, because I'm starting off by calling all of this is P. So log P is equal to 0. So let's start by finding out what P is. Okay, don't forget that there's an invisible base 10 right here. So if you sort of rewrote this in exponent form, then we'd starting with the base, so 10, and then you know how these are going to switch places. So 10 to the 0 power is equal to P. Well, what's this? Anything to the 0 power is 1. So that means P is equal to 1. Okay, so we are 1/3 of the way done. If we know that P is 1, then let's start over with that fact. Okay, so look, P equals 1. Now remember what I said P was. P is everything here in yellow. So that means everything here in yellow should equal 1, because that's P. So let's go ahead and make that substitution. So that means log base 6 of the log base 5 of x must equal 1. I just substituted in for P what it is. Okay, so we're going to do the same process again, but we're done with P now. Now let's talk about Q. This is Q right here. Okay, that means this right here is Q. So this would be the same as having log base 6 of Q equals 1. So let's figure out what Q is so we can move forward. Again, if we rewrite this in exponent form, starting with the base, so we'll have 6, and these will change sides. So I will have 6 to the 1 power is equal to Q. Well, obviously 6 to the 1 power is just 6. So that means Q is equal to 6. Okay, we're making progress. Alright, so Q is 6 now. So let's start with that fact. Q equals 6. Now, once again, let's make this substitution. Alright, what is Q? Q is everything that's highlighted here in yellow, log base 5 of x. So that means log base 5 of x is equal to 6. Now, this is an equation we can solve. This doesn't scare us. Once again, we will rewrite this in exponent form, starting with the base. So the base is 5, bring that down. These two things will switch sides. So we will have 5 to the 6th power is equal to x. Alright, and this is what we're looking for. We're trying to find the value of x. We can get this off the table. 5 to the 6th power. Alright, that's 15,625. So that is your final answer. Alright, now I know that was just like, I just totally blew your mind with this problem. And that was intentional, okay? Sometimes I have to do that. It's my job. Please do this problem over and over and over and over again until you can do it yourself without watching the video, without looking at your notes. I can almost guarantee you will see this problem again. Alright, but for now, that is the end of this particular lesson. I hope you found it helpful. I will see you on the next video.